I'm happy to announce to you David King.
Thank you very much. Thank you. Right, so I'm David. I'm a developer at Red Hat, where I've been for a couple of years. For a large part of the time that I've been at Red Hat, I've been working on GNOME. I also do a few other things like packaging in Fedora. I obviously do a bit of work on Realm and things like that. But logs is one of the things that's been taking up a fair bit of my time. Not so much recently, but there's more to talk about that later. So I'm going to talk to you about not only logs, the application, but also sort of the current traditions of logging in Unix and Linux, what we're now doing with the journal, how logs helps us actually digest that and make use of that, and some examples of logging, how we go wrong, and the things that we can improve in the future. So, what is logging? It can mean a lot of different things to a lot of different people, and in pretty much every application you'll get it implemented in a slightly different way. GTK makes, or rather GUADEC makes it somewhat easier by providing a nice interface for it. But a lot of the time it's debugging information. So if a programmer has written an application or some other thing that they're using, they want to omit some useful information to the log, so that at some point when something goes wrong, they can figure out what went wrong. Diagnostics as well, maybe you're testing the performance of something, you want that logged in some way, so like GStreamer has a very comprehensive framework for doing different log levels and things like that. Programmer errors, so if you've ever seen logs of things like a G return if fail, warning, something like that, some critical error that you get where you set an assertion at the start of a function which then fails, the programmer generally wants to know about that. Whether that crashes the application or not, it depends on which environmental variables and things you have set. But those are very, very useful. And a lot of useless crap. If you look in your logs, there is a huge amount of stuff, even on a normal desktop system, that is of very little use to the average user. There's a lot of things that the user doesn't need to know about, shouldn't need to know about. I mean, their system booted correctly in most cases, so why are there all these logs? I'll talk a bit more about that later as well. So, where do you actually store your log messages, or rather, where do you output your log messages to? If you're the kernel, then you can read these with the dmessage tool. It outputs them to /dev/kmessage, I think, or at least that's one possible way that it can output them. I think it's in the Bring buffer nowadays. So you can check what log messages you have from the kernel using the dmessage tool. Most of you are probably pretty familiar with that. You get a large amount of logs for your startup from the kernel, but other than that, when it's running, it's just depending on which hardware and things you plug in. Standard out and standard error, pretty obvious and pretty normal. If you're a system daemon, then this is pretty much the only thing you can do other than files in /var/log, or maybe if you're a user session daemon in .cache or something in your home directory. Obviously, the venerable syslog. This is a call that is actually specified in POSIX. So that in itself is quite a nice thing, but where that then eventually ends up is not necessarily very well defined. Some applications, if they're really particularly retro, have a log that's actually in the UI if you just want to confront the user with more useless crap. But it's not something we do very much. So traditional logging in this sense is very unstructured. It's very, very simple. It's generally a line of text when there's a log message. Often, if you're logging something from the kernel, it'll be a lot of lines of text. So a particular subsystem will become initialized, and it'll say, like, copyright this person this year, and then you'll have 10 lines about the authors, and then maybe at the end you'll actually have something useful like the version number of that subsystem. So it's kind of both a benefit and a real drawback of this system. Because it's so unstructured, you get lots of useless stuff that's put in there, and it's very difficult afterwards to examine this from a machine point of view and get some useful information out of this. One benefit of it from the user space side is that if you are using the syslog call, it is part of POSIX. So you can depend on it being there, not just on Linux, but on other systems as well. That's pretty much all it's going for, in my opinion. I mean, a lot of people would say that because you can use grep and the plain text files, this somehow makes these things a lot easier to consume. There is an element of truth in that, and that it follows the Unix tradition of everything being as simple and as least as unuseful as possible. But we can actually do better than that nowadays. Of course, the drawback is, as I've said, these are just text files quite often. You can't actually pass them as a machine very easily. People have tried, and you can get a certain amount of the way there, but not all the way. Because there is no standard format, you have quite a lot of problems. For instance, if you're logging and the time zone changes, or if you're logging and you go through a leap second or something, how do you know that what is actually being given to the logging daemon has the right timestamp on it? You can't verify a lot of these fields if they're just in a plain text file, so you can't in many cases. You also can't verify the sender of the message. So if you install a rootkit on a system and you just send a lot of messages to the logging daemon with syslog, and you decided to fake your PID, you could do that and get away with it in most cases. And it's very difficult to then afterwards trace that. Ordering of messages is not guaranteed. That's kind of annoying because if you get several different processes logging and say one of them beats the other one, you get these logs that are interleaved that seem rather confusing, and why did this failure happen before this thing where apparently this succeeded? It's just confusing if you're actually then trying to diagnose something after the fact. Of course, like everything, systemd fixed it. So with systemd, very, very early on, there was the idea of the journal. This is a daemon, systemd journal that has actually started very, very early on during boot. It started so early that it sort of hoovers up the kernel log messages that have currently been output, and it then persists through to the real root once you actually get to that point, the full system, and then flushes all of those logs to disk. So that from very, very early on, you've actually got all of those log messages on your system. So even if something happens in early boot, you can generally figure out what the problem is. Something that a lot of people who've been involved in Unix for a very long time and maybe have long beards, they don't like the fact that this is a binary logging format. I mean, if you ever open one of these files in hex editor or something, it's binary in the sense that you've got lots of binary data fields in there. It's a file, but on the other hand, you have the message fields in there. If you were worried about there being data loss, the files themselves are actually pretty robust, and you can go in there and open it and figure out what these text messages of these log events are. So I don't think that's of particular concern. One benefit of this binary logging format is you can do a lot more with it. You can put all of your logs into one file, so all the logs from the kernel, the system daemons, from the user session. You can put all of those in one file, or at least you can put them in one file format, so that you have a consistent way to then access the information about those logs. Not only that, but you also have an API to push information to the logs. So whereas the syslog API is essentially one function call, where you say, I have this particular log message, it's got this particular severity or priority, I think is actually the terminology. That's pretty much all you can do. With the systemd journal APIs, you can add essentially any arbitrary metadata that you like. If you want to push a binary blob into the journal, you can do that. That doesn't immediately sound useful, but on the other hand, say you have a crash, you want to put a core dump in there, then you can then access that much later on, and you can do some debugging, and it's in your logs directly. You know when it occurred, which process it occurred on. Very, very useful. And of course, because there are APIs to put data in, as you'd expect, there are also APIs to get this information out. And that means that rather than every logging client or UI having to pass this text file or this multitude of text files in its own way, we have one interface, one API for this, and it's quite nice. Of course, GNOME already had, or has, or did at one point have, a logging UI, GNOME system log. And a lot of you may have used this in the GNOME 2 days. It's quite a useful application actually. I did use it occasionally. It basically gave you a list of all of the different log files that it found on your system, based on some predefined list of where these files might be. And then it would just give you a big text view of this. And I mean, I guess that kind of demonstrates the weakness of this approach, that essentially all you've got is a big blob of text. You could find things in this with a search tool and things like that. But other than that, it wasn't super advanced, because it's very difficult really to have something so unstructured and to make something useful out of it. As well as having this sort of quite retro UI, which is basically just a sidebar, which was a tree view and I think a text view on the right-hand side. One of the things it had to do to access a lot of these log files was run and root, because these files are actually generally owned by the root user and not readable to other users. This is kind of a problem because various things break in that situation. Obviously, running GTK applications as a root generally is frowned upon. And then things like the app menu didn't work because it couldn't connect to the session bus. So it was a bit of a difficult one to fix. And I think the idea was really to have something new and something different. So this is what it looked like. And yeah, it's pretty much what you'd expect. It's a very traditional log viewing application. And then the idea for a new logging UI came around, GNOME Logs. This is based on original designs that John McCann made quite a while ago. He investigated a lot of different approaches to logging. He looked at a lot of other platforms. So Windows has a kind of similar idea to the journal. It has this system logging service that you can push logs into. macOS has a kind of better log viewer. But a lot of them still don't really take full advantage of the fact that you have this useful API. And they don't use that to actually simplify what you're presenting to the user. And that was really kind of the approach that he took, to really condense things down as much as possible and only show the problems that were most important, the problems that actually the user needed to pay attention to. I mean, they could get access to the other things that they wanted, but by default, it would only give you the severe warnings, the ones that you needed to worry about. So I started quite a while ago, September 2013 was the first release. It was already somewhat functional then. I mean, you've got a list of log items. You could click on them, you could get more details. One of the nice things about it was because it was a new project, although it's written in C, because a lot of the system, the APIs are in C, and it just seemed easier to do that. It was kind of a nice idea to just play with the new technology that we had in glib and GTK. So we used like widget templates and gResource when these things were still relatively new. That was quite fun. It's because it's quite small, it's also something that's relatively easy to hack on. And I mean, I think it's only, it's only sort of 5,000 to 10,000 lines of code. It's somewhat small for C. And this is pretty much how it looked. This was relatively close, actually, to the original designs. It's changed now, and I'll give another screenshot later. But you've got this list of categories on the left, and by default we have important selected. So important is essentially the log messages that are more severe. I can't remember, I think it's warning severity or higher, or error severity or higher, something like that. These are based on like the traditional syslog priorities of these messages. You'll still see that some of those messages there are kind of useless. So like we have the abort daemon saying, an init complete entering main loop. Well, it doesn't really seem like a very important log message. It's just starting up, that's just debug speed really. And there are a few examples of that, but that's actually, the situation there has improved. And a lot of those messages have now been dropped down to less severe warnings. But you can already see, there's a decent UI forming there. It looks like a GNOME 3 application. You've got your header bar, you've got a search toggle there. It actually has type ahead find. And these were essentially all of the features that were in the initial designs. So filtering by category sort of works. One of the nice things about the journal is you can actually figure out where the messages come from. So you can say, I only want to view the messages that are coming from the kernel transport, and it will only show you those things that you would normally get in dmessage. You can say, I'm only interested in processes that this user has started, and it will give you those. So because you've actually got kind of a rich filtering and matching API, you can already implement a lot of those categories with very, very little code, just sort of almost a one-line match rule. And that's pretty neat. It's a lot easier than it would have been with a text file and a regex. There's a detailed message view which I didn't show you there. You can click on a particular log item and it will reveal more information about that particular message. Basically all the metadata that we pull out of the journal for it. But you can actually pull a lot more metadata out of the journal than logs does. It didn't seem like a particularly good approach to just get everything you can and present it in the UI. I mean, that in itself isn't useful. If you want to do that, I mean, the journal CTL is a very capable tool. This is just something that shows you a few more things than maybe you can or would want to in a list. Type-ahead search works as you would expect. So what happened after that time? Well, John didn't have a great deal of time to work on it. So there wasn't a great deal of sort of UI changes. There were little features there here and there. I got lots of nice bug reports from new users who were kind of interested and who said, oh, well, the sorting is in the wrong direction, so maybe there could be a toggle for that, so I kind of put in a hidden GSEC for that, because a lot of users actually expect their logging to be much like it would in a text file, that you append new things to the end. We actually did it the opposite way. We had important messages and new messages especially bubble to the top. But some users still expect it the old way. That's something that's easy to satisfy. And then after that, there was just sort of little things. But Lars came along and we were chatting about improving GTK listbox at a developer experience hackfest. And him and Ryan Lawty have been coming up with this idea to have a model behind GTK listbox. So GTK listbox, if you're not aware, is the sort of modern GTK replacement for most uses of GTK tree view. So where you use tree view for a list of items, you're not really using it as a tree view, you're using it in a sort of very simplified case. And a lot of the time you want something more than the tree view can provide. You want something where you can add buttons or some other proper widget tree to each row, because you're limited with a tree view with cell renders. It's kind of very good if you have tabular data, not really so good if you have anything else. We were starting to have more interesting things there, so we actually wanted to use GTK listbox. We did. We had some extra widgets there. We wanted to then put a model behind it, because otherwise, for each row, you have to worry about creating all of these widgets yourself and things, and it's really something that we'd like the API to do for us. Lars put in a lot of work to the list model itself, and looked at logs a lot. And I think it was one of the first users of it. It was kind of his prototype, really, while he was developing it with Ryan. Eventually that work got merged into glib, and basically as soon as there was a release there, I could depend it in logs, and I did, and I think, I can't remember that, I think that was like the last cycle, so sort of 316, we had all that coming in, and that's really cool. One of the other nice things that allowed us to do is to do on-demand loading. So what logs would previously do is it would take the current boot up and would give you all the log messages for that. This is fine if, of course, you work with Red Hat and they give you a nice new laptop and it has an SSD. It's really fast. But then what you find is that if you use the journal on some old rotating disk, then actually it's kind of slow to use a match rule and go through and iterate over all of these log items. So that was actually kind of too slow and too annoying. So with the new signals that you now have in GTK scroll window, you can actually tell when you get to the bottom or top of this list, and you can then page in extra items. So he did that, and that was kind of a simple patch really when it came down to it, but those features appeared in GTK and we made use of them. So that's now a lot more responsive. We also used to load, I think, items in blocks of 10, which again, if you're on an SSD, isn't a problem. It now just loads each individual item as soon as it's required, creates a widgetry on demand, and it's pretty fast. I mean, I'm sure it could be faster, but currently everything's done in the main threads, so it's about as good as it can get, I think, at the moment. Something really exciting that's happened this year is that we've had 2 summer code students working on logs. So Jonathan Kang and Rashi Aswani, they've both been involved in GNOME for a while. So Jonathan came to me pretty much a year ago, I guess. So he was interested in working on some applications and what could I help him with? And I said, oh well, I've got this small application I'm developing. It's kind of nice and small and probably a good introduction to GNOME technologies if you want to have a play with it. he started submitting some really nice patches. So I then, after a few of these really good patches and going through and reviewing those and mentoring him with those, said, well, you should apply for a summer code project. Just running when you're a student, it'll be fun. He did. He's been actually doing some really, really good work there. He gave a presentation at the Intense Lightning Talks, which you may have seen. He's been working on some really, really awesome features. So we've now got searching by journal fields. So each of the metadata items that you store in the journal, it has these particular fields attached. You can now actually prefix your search term with those, so that you restrict that search term to those fields. It's a really, really cool feature. It currently is just a subset that we have that we pull out of the journal, but we're going to be extending that to all of the metadata fields that we have in the journal as an enhancement later on. So you've been working on loads of other stuff as well, and blogging about it a lot of plant node, so that's good. Rashi's doing some really, really great work on testing. So not only has she been looking at unit tests and the framework that we're using there, she's actually been writing lots of really cool UI tests and behavioural tests using Behave and Dogtown. So she was previously a documentation intern, and she's now kind of graduated, if you like. She's now moved on from documentation. She's now hacking on logs, and it's been quite difficult. I mean, the test stuff is always a little bit of a difficult thing to set up, I find, especially if you're like me and you use non-recursive make, and then you want to somehow get all of the test suite into there. But she's managed to deal with that really, really well, and I'm very proud of both my students that are doing really well. So I think they deserve a round of applause. So this is how logs looks now. It looks quite a bit slimmed down. So this is based on some really good work that Alan Day has been doing with more recent designs. We've simplified the list view a lot. This is based on some recent refactorings. He's actually provided us some new designs, so we're going to slim this down a bit more and change a few things here. I think everything is now going to be monospace fonts, just so it's consistent on the event view that you have on the right. We've also slimmed down some of the categories for the things that weren't properly implemented until we actually have time to implement those. So there's really quite a lot of stuff that's actually gone in here. We've now got these columns, and it's just a much, much more responsive application. We've got a window menu there, but that's going to change soon as well. That's some more work that Jonathan has done on being able to select the particular boot that you're viewing. So previously you can only use the single boot of the currently running system. You can now go back and select, say, the last 5 boots or something like that, and restrict to those. So that's much more useful for sort of post-mortem diagnosis. In terms of what we're going to do in the future, there is a lot that can be done. It's still quite a small application. I sort of try when I review to keep these patch size down. So it takes a little bit of time, but it's growing slowly. We want to group log entries by application. It's currently, or previously at least, has been difficult to actually group these things nicely. Often you'll get an application that will log 10 lines of sort of spew all at once. And that is something that is very, very difficult because as the consumer of that information, you know the timestamp on it, but you don't really know whether that's related. Is that 10 discrete errors? Is that 10 things that all correspond to the same thing? So we're hoping to come up with some good heuristics about how we can sort of compress those log entries down into one thing. So a lot of the time you'll get something like, say, a plugin for Firefox will be there and it will load and it will just output loads of credit at the beginning when it starts up. But it'd be nice to squash those down so that rather than having these 10 discrete entries, you have just one. It's pretty difficult, and I think the heuristics, I don't know how reliable they're going to be. We've done a little bit of work on it, a little bit of research, but we need to do a lot more there. This application grouping is kind of tough because it depends on the launching process. So at the moment, Gnome session is still launching the processes in the user session. So when you click on a desktop file or something like that, often Gnome session would still get all of the log messages for a particular application. This has been improved a lot. Colin Walters wrote some nice code that was kind of a quick hack really, but actually makes sure that each of these processes gets logged separately. Now we just need to kind of take advantage of that logs and actually group those together then. Message UUIDs. So this is an example of the structured metadata that I was talking about earlier. You can associate a UUID with each message. So there are UUIDs for things like when the system reboots, when a service has started, when a service has stopped. They're 128-bit, so they're essentially unique anytime you generate one. And you can add these yourself, so if you're a long-running daemon, you might have a particular message for like an incoming client connection or something like that. We don't do anything with those at the moment in logs, we don't recognize those. Systemd has quite a few of these UUIDs that are kind of well-defined and well-known and used in several places. So we should really actually process those and display those differently in the event view. It's probably kind of a nice little hack to sort of do to just change the appearance of some of these log view items. Another thing that we don't yet do, and that is a lot harder actually, is message alerts. I mean, from the UI side, this is a relatively simple thing. You go through the logs, you're walking and iterating through, you come across a message that's interesting to you, and you give some notifications. So, say your hard disk is failing and there's a smart error, then it would be nice to be able to monitor your logs and create some notification about that so that the user has at least some knowledge of what's going on. However, that means that every time a log message comes into the journal, you've got all of that machinery going to get that message actually there, and then you have to then monitor that, pull it out again, process it all. So that can be quite heavy. What we'd really like to do, rather than doing that, having something running but essentially polling all the time, is have Systemd tell us when something interesting happens. I don't think the Systemd API for the journal reading actually has triggers yet, and that's something that we've talked to the journal guys about. They want to improve it, but it's probably something that we're going to have to do and help them with. So we need to go into some Systemd code. Another cool idea that Tim Woe actually came up with, he's a guy who works on lots of cup stuff, I think, lots of printing stuff. He thought it would be a cool idea to, out of these core dumps that you get put into the journal, pull those out, run them through GDB, and actually, one of the nice things about if you use a Systemd logging APIs is you get the source code line of the particular statement where the log message was coming through your application. You actually get that included in the metadata that comes along with the log message. So you could then, if you had the debug symbols for that installed, you could go and pull out the source code lines around that and say, yeah, well, you have this assertion, you have this log message, and here is the source code. You're the developer, you can fix this. He actually gave kind of a 300-line Python script proof of concept of this, using GTK source view to show all this, which seemed pretty neat. To get that into a nice workable state in logs would probably be quite a bit of code. I mean, it could be quite a long project to really make it nice. But it's something that I think would be pretty cool for the future. So I talked earlier about a lot of the problems that we have with logging, where we have a lot of logging. And as an example, I booted my system up here today, and just sort of counted some lines really. So 3,000 lines of log messages are generated when you start up a sort of standard GNOME desktop running Fedora. That is both user and system logs, so it's not just like your kernel, it's also like everything that the session starts, it's like the Xserver, all these sort of things. So 1,000 of those lines are from the kernel, so a third of the log messages when you start up from the kernel. Some of those you could probably slim down a bit, but really that's just like a one-off cost. And it's like the kernel enumerating hardware, loading drivers, loading modules, probing things. I'm not too worried about that because once the system's running, you don't really get very much of that anymore. If you plug something like a USB here, yeah, you get a few lines, but it's actually not a great deal. So the kernel generally behaves pretty well. I mean, it'd be nice if that like ACPI dump at the beginning, which was like 100 lines of just random memory maps, was not there, but it's probably really useful for kernel developers. And I mean, we could pass like a silent flag and never see it, but I don't know, that's not really what bothers me. 400 lines from Xorg server startup. Yeah, that's a little bit annoying. It's mostly 400 lines of, again, enumerating what hardware you have, like which monitors are connected, which video cards do you have. A lot of it isn't super useful because it was probably from a time when we used to have a configuration file, so when it actually mattered, what of the messages, when it mattered like screen 1 or screen 0 and things. Nowadays, probably a lot of that isn't that useful, so we could probably get rid of a lot of that. 150 lines from the user session. So this is actually separate from that. It's things like applications starting up and registering a well-known name on debug, and the session manager saying, yes, I see this well-known name. Not so useful, but then there aren't really a great deal of errors there. I mean, there are also other things like you will get assertions and things where, I think GDM, there's a bug where it tries to create a variant from a string which doesn't happen to be UTF-8, so there's a warning there. And that's something that I would like to see fixed, all of these sort of warning messages essentially that just go, they persist for a very, very long time and they're never fixed. Logs can hopefully help a little bit. And yeah, the remaining 1,500 lines, that's from all the system demons. So that's like things starting up, telling you what they're doing. There are a lot of system demons, even now, on a modern desktop Linux system. I don't know. I still think 1,500 lines is way too many lines when you're starting up. I mean, that's more than the kernel, and the kernel interfaces with a lot of hardware, so I don't really see a great excuse for all those system demons to log that much. But that's probably a harder sell than fixing desktop, which we have more control over. So one of the fun things that you get is all your search providers, when they get loaded, you get told about all of those in your logs. I don't know, maybe that's not so useful. Maybe we can come up with something a bit nicer there, just a list of all of them. But as I said, this is like each line of these is a line in the log. So you get a line for activating, a line for successfully activating. Great. Tracker, well, we all love Tracker. Yeah. SE Linux, well, we all hate SE Linux, so that's fine. Those are just some sort of examples that you've probably seen many times of the bad behavior that you really get with log messages. I mean, those are examples where you've got 20 or 30 lines, but really 2 or 3 would have been sufficient. Some of them we can fix, some of them are harder because they're not really what them developers are going to be developing. I mean, we should probably just file bugs against these misbehaving applications and these misbehaving subsystems and get it resolved, because the amount of spew that you have there means it's actually difficult to zone in and figure out what is the problem and what is the thing that the developer who's working on this particular project needs to fix. We've now got more tools to be able to do that. Logs is one of them. I mean, it was kind of cool the first time I used it to actually debug something. You know, I still use journalctl a lot, but the filtering of the logs is pretty nice and it works well. So I hope it can help people debug things. The program errors that I talked about, like this UTF-8 string not validating correctly, those are things I would really like to see fixed. It might be easier to fix those if we actually take advantage of more of this structured logging, because at the moment, glib logging stuff that I talked about earlier, just logs as text, like everything else. So you have to look for sort of those warning strings that, you have this tracker warning here. You still have to look for something that looks like it's coming from a glib application in order to figure out where it is. I've prototyped a log handler where it can actually log to the journal directly from all of the standard glib logging code. I think that would be kind of a nice thing to have. Maybe enabled by default, maybe not. I've spoken to Ryan, the glib maintainer, about it, and he's sort of positive about the idea. Doesn't like the idea of linking to systemd. This goes back to the portability concern I mentioned earlier, that syslog is a very easy thing to depend on, even for the BSDs and everything, it's completely fine. Probably if we start using journal APIs and glib, they're going to get a little bit annoyed. But on the other hand, it's probably something that we can isolate to some separate module or some optional feature. And I mean, the log handler can be changed, right? So it's something that can be patched out if they don't particularly like it, and they can just use the traditional printf-based log. It's fine. Yeah. If we take advantage of this structured logging in glib, that will already help us get our platform in order. And really then it's a case of getting more things using this structured logging API. The kernel is still sort of improving in that regard. It used to be pretty bad, and it's gotten better. You can get more information out of the kernel logs, like which device a particular log message was generated for, and things like that. I think that will improve over time. And now that systemd is kind of the de facto layer above the kernel, I think that it's more feasible to actually convince kernel developers that it's a good idea to make use of it. So we'll sort of kind of see how that goes with the kernel. So I'd just like to once again thank my summer code students, Rashi and Jonathan, and Lars for helping out a lot with the list model code. And thank you very much for listening. Are there any questions? There's Mike at the back. Mike has a question.
Who has a question? So my question is, what gets logged? Like, presumably, if an application writes to dead area, it's going to show up in GUADEC logs. This is to be general, but did out get logged, or?
Yeah. So if an application's running started by name shell, then it will actually log. Well, the shell will have set up. I don't know whether it actually sets up a C group, but essentially what it does is it logs to the journal as that application. If you run it from a terminal, then it doesn't. Then you just get a log message printed directly to the terminal because there's no shell controlling it that does any of that setup. You can, if you want, log directly to the journal. So this is the idea with, say, a log handler that you put into glib. You then get all of these messages rather than coming to stand out or stand error. They go directly to the journal. Obviously, for debugging, you're not necessarily going to want that. So maybe you then have another environment variable, but you already have like G debug, or what is it, G messages debug, where you can set all of those. So polluting that even more, maybe not so great. I guess a lot of this is a problem because users don't see these messages, which I mean we don't want a user to see these log messages. That they're really quite developer specific. You know, the user can't make sense of them. To be able to consume them and actually do something useful for the developer, that would be great. But then if I think we can do it for our platform, maybe for some of the components that we build on. Other than that, I don't know how much take-up there's been of the journal APIs in, say, KDE. I think they have kind of a log viewer thing that's similar to logs. I don't know whether they have anything else that can consume it, or whether there have been a sort of attempts made to do so. I don't know. Did that answer your question? Or should I? Yeah? Okay, thank you.
No more questions?